Now we have this question. You have this boat, you see? You're the right at A. And you want to sail the boat straight across to B. 90 degrees to the bank of the river. This is the river, right? You have the river. And it will flow this way at 5 kilometers per hour. Now your boat engine, make it go 10 kilometers per hour. You see, if the river then flow, could I just point it straight across and go to B. But the river flow 5 kilometers per hour. So if you point it straight across and go to B, right? Straight across we go to B, the water go and push it so that it's some distance down the river from B when you go to the bank. You don't want that. You could have carried the boat some distance up the river and go across so that the water push it down. But you don't want that either. This is where you're there. And you want to go straight to B. So you must point the boat at an angle. So as the boat go across, right, at one point the boat to the there so. Then here so again. Then here so again. Right? So this is the situation so that the boat go across to B. The question is, what angle? What is the angle? Theta, you must put the boat so that it goes straight across to B. Alright, what you're going to do, see, is cut up the vectors in the horizontal and vertical components. You have a horizontal component and you have a vertical component. Alright. We could consider the angle. Not here. But here. This angle, theta. Now, we could call this I and this J for the boat. Alright? Now, here, you remember, say, this 10 kilometers per hour, you're going to cut up into two parts, horizontal and vertical. The horizontal component would be I cos theta plus the vertical component J sin theta. Alright? I cos theta plus J sin theta. That's going to give you the 10 kilometers per hour. Right? And by the way, the 10 are the magnitude of V. Right? So, the velocity of the boat, magnitude of 10 kilometers per hour. Oh, we shouldn't write this 10 here. This should have been the vector V. This is the vector V. Right? With the angle and the... Now, the thing is, since the magnitude of V, the magnitude of the vector is V, which is, the magnitude of vector V is 10. Then, the horizontal component would have been 10 cos theta, and the vertical component would have been 10 sin theta. Oh, it's my mistake. But let me redo that part again. Alright. The magnitude of this vector is 10, because it's 10 kilometers per hour relative to the water. Now, V, the velocity, is I times the magnitude of V, 10 cos theta, plus J, the magnitude of V is 10 sin theta. Alright, good. Now, here, the horizontal component at 10 cos theta, the vertical component at 10 sin theta. Alright? So if you should draw a line like this and measure it, this would have been 10 sine 10 cos theta, and this line would have been 10 cos theta. Alright? So that part is that. So we draw a diagram and label it. This is the boat with, this now looks so vertical, this so horizontal. Alright, good. So you have this a V, this a 10 times cos theta and 10 sine theta. I have the angle because the magnitude of V is 10, right? The magnitude of V is equal to 10, and this is the angle. Now, as for the river is flowing at 5 kilometers per hour. So you have, call this UV, call this W, is a vector that represents the river. So it's 5 cos theta. It's just 5, right? 5 cos theta would be 0. So it's 5 cos 0 times I. Cos of 0 is 1, because the 0 comes from the fact that between the flow of the river and the horizontal is 0 degrees, because both of them going horizontal, right? So you have 0 degrees here. So it's 5I. Alright? So that is what you have. So therefore, what you're going to have then is 10 cos theta I plus 5I. Put the i's together, we're adding the two of them, plus 10 sine theta j plus 0j, because the flow of the river does not have a j. It's 0j. No up or down to it. So then, the velocity of the boat is at 10, if you put these two together, 5 plus 10 cos theta I plus 10 sine theta j. Alright, so the j part shows the velocity of the boat straight across, but the I part now shows the velocity of the boat horizontally. Now this part, the 5 plus I cos, plus the part, so let's say 5 plus 10 cos theta is supposed to be 0. Because when you combine both vectors, you're not supposed to shift left or right. You're supposed to be going straight across. So the I component must be 0. So 5 plus 10. Let me write this properly, make it look like 10. Kind of look like I. Earlier I may call it I. So 5 plus 10 cos theta is supposed to be 0. Alright? And by the way, we can call this W. Oh, me use W up here again. Call it WXY. Call it Y. If you consider both vectors added together, both vectors added together, the v and the w, y equal v plus w. You call this y equal this at the v part for the boat and the angle, right? This part, and then the w part would be for the flow of the river. All right, so boat velocity plus river velocity. So in this case, what you have is when you put them together, you say this and this combined, 5 plus 10 cos theta equals 0. Because the horizontal component of y is equal to 0. That means when the boat go across, it must not have any horizontal, it must not shift left or right, it must just go straight across. You have a vertical component, right? Which is 10 sine theta. You write 10 sine 0, 10 sine theta j. And the horizontal component must be 0, so make this 0. So you say 5 is equal to negative 10 cos theta. Negative 10 cos theta equal 5. So cos theta is negative 5 over 10, negative half. What's the cosine of negative half? Oh, what do you say? You say theta is equal to cos inverse of negative 0.5. What is the inverse cos of negative 0.5 again? We'll see what happened here. So cosine inverse of negative 0.5 close bracket equal, and we have 120 degrees. So that means all of this angle is 120 degrees, but you want to find theta over here. So what we call this theta too, you know. Theta would have been turned out to be all of this. So 180 minus 120 equal 20, 30, 40, 50, 60, 70, 80 is 60. It look like 60 degrees it would be. Alright, so that's what you have there. So basically, you point the boat 120 degrees away from the direction where the river running, or if you turn the boat up from where the river coming, you point it 60 degrees from that direction. Alright, so that's it for now.